Okay, so in this video, we're going to look at vectors and what we call R2. So R2 is basically two dimensions, right? So we're going to be studying vectors in R2, two dimensions, and then vectors in R3, three dimensions. So I want to preface this by saying you know more about vectors than you think you do. And that's going to become very clear as I go through this video. So first of all, R2 is your XY grid, right? Two dimensions. So you can see here I've already got this point plotted, 2, 3. So if I start here at the origin and I do this, that's a vector. The tail's at the origin, I can say 2, 3 is the point. So I can say that is vector OP, and that has the coordinates 2, 3. Now we've been plotting points on the XY grid forever, so basically you've been working with vectors forever. So what we're going to do here, though, I want you to see what I have done here. I've also plotted -2, -3. So if I do this, right, what would that vector be? Well, that would be the opposite of OP. So the opposite of OP is negative vector OP, which is -2, -3, those coordinates. So you can recall we talked about opposite vectors, that they are the same magnitude, but they go in opposite directions. So I want to show you something cool there, right? So let's go back here. OP was 2, 3. So then if we put a negative in front there, this is what I've just done right here, right? I've just shown you that. I just changed the vector OP with the coordinates. So think about, what would you normally do with that? So you think of it like this. Think of it as -1 distributing through. And you would get -2, -3, which is exactly that vector we were talking about. So keep that in mind, that you already know how to do a lot of this stuff. Okay, so a couple definitions. So when we refer to a position vector, that's when the tail's at the origin. So that's exactly what we have here, right? OP, that was a position vector because the tail was at the origin. Same thing with the opposite, right? That's also a position vector because its tail is at the origin. So another definition that's going to come up quite a bit, I'm going to highlight both of those. So whenever we hear unit vector, that's going to be a vector with a magnitude equal to 1. So remember, magnitude is the length of a vector. So any vector that has a length of 1 is referred to as a unit vector. Now what's really cool is that in R2, XY grid, we have something, or a couple of things, that are standard unit vectors. So standard unit vectors are the vectors I. We're always going to use I with that vector symbol above. So whenever we see this, whenever we see vector I, that's the vector 1, 0. That lies on the x-axis. And vector j, whenever we see vector j, that's 0, 1, and it lies on the y-axis. So here's something really neat. Every vector in R2 can be written as a combination of I and j. So, oops, I need my pen. So let's look at the vector A. So the vector A is 4, 6 on the XY grid. I can also write vector A like this, as 4 times vector I plus 6 times vector j. And I can prove it. So let's go here. Now, we said vector I was 1, 0. So I'm going to place vector I of 1, 0 because that's the coordinates of vector I. Vector j is 0, 1. I'm going to replace vector j with the coordinate 0, 1. So I want you to look at this, and I want you to do what you would normally do. And this is what I mean by that. When I look at this, 4, to me that's 4 times 1, 0. So I'm going to distribute 4. I'm going to multiply through by 4. 4 times 1, 4 times 0. Same thing here. Oops. I'm going to multiply through by 6. So 6 times 0 and 6 times 1. Now, when you get down to here, I want you to do what would make the most sense. See, what would make the most sense is that because they want you to add here, it would make more sense to add the x coordinates. So 4 plus 0. Well, 4 plus 0 is 4. And you add the y coordinates. 0 plus 6 is 6. So every vector in R2 can be written as a combination of the standard unit vectors I and j. So, let's look at another one. Let's say like vector b is -9, 7. So if your task is to write that as a combination of I and j, okay, sometimes you have to go in between the two. Sometimes you can just pick your most I guess you call it your favorite way of writing it, right? So if you have to write it as a combination of I and j, just remember that vector I goes with the x coordinate and vector j goes with the y coordinate. So I can just do this. I can see -9 is the x coordinate, so I'll just attach the standard unit vector I there. And then of course you want to add, and I can just attach the standard unit vector j to 7. So likewise, if somebody gave you this, if somebody said like vector x was 32i, vector I, shall I say vector I, minus 47 vector j, and we wanted to write it just with the coordinates, right? So I could go back here to this process here, right, where I substituted 1, 0 and 0, 1. But we already know what the outcome is going to be to that. So you can kind of think of it like this, right? You can kind of just set up and go right to your coordinates. This right here, 32, because it's multiplying vector I, is the x coordinate. And this right here, minus 47, don't forget that minus, because it's multiplying vector j, is the y coordinate. In the next video, I'm going to show you how to calculate the magnitude of a vector.